Hi there, this is video 8.2. We're going to start using some conversion factors, which is fun. I haven't done it in a while, so this will be cool. First thing, this weird little symbol, which is an equal sign with a dot, basically means approximate. Cool too? So 1 kilogram is about 2.2 pounds, and 1 kilometer is about 0.6 miles. Okay, so let's get started. Which tank has a greater drainage rate? It takes 4 hours and 15 minutes to drain a tank which holds 300 liters of water. It takes 2 hours and 10 minutes to drain a tank which holds 150 liters of water. Well, obviously tank B drains faster, but we want their drainage rate, like the unit rate, how many liters per minute or liters per hour we're losing. And that's part of the trick of the question. Is what in the world do you do with that? Because you've got two different units there. It's like 6 feet 3 inches. Right? God bless a metric system. You just make it all meters and you put decimals in, and it's all easy. All right, so we could convert this into hours, or we could convert it into minutes. And our question doesn't give us any indication which would be better. So my usual choice is I will convert to the smaller of the two units. It usually makes life simpler. So 4 hours. I'll put tank A here so I know what I'm doing. So 4 hours and 15 minutes. There are, y'all know this, there are 60 minutes in an hour. So that's going to be 4 times 60 plus 15. So 4 times 60 is 240. 4 times 60. Well, you can't see anyways. 240 plus 15 is 255 minutes. Oh, another thing I didn't write anywhere on here. It is probably in your best interest to always keep your units on there so you remember what you're doing. So we want to know liters per minute. So for tank A, it is a 300 liter tank divided by 255 minutes. We can keep our units there. Divided by 255. 1.18 liters per minute. All right. Now let's go tank B. And tank B was 2 hours, 10 minutes. So that's 2 times 60 plus 10. 2 times 60 is 120, so that's 130 minutes. And I want liters, please, per minute. Old habits die hard. Get used to writing your fractions with a square bar. You'll see in a minute why that becomes important. Liters per minute, so liters was 150 liters over 130 minutes. No, you're still seeing black there. 150 divided by 130, 1.15 liters per minute. So the first tank has a slightly faster drainage rate. You could do liters per minute. You could, if you wanted to, flip all of these and do how many minutes does it take for a liter to go, and you'd still get a comparison. Either one is fine. Most often with rates and stuff like that, time usually tends to be, it's per minute, per hour, per whatever. All right, so For each of the following, compare the two rates and determine the lower rate. All right, we got whole chickens, 361 a kilogram, or 10 pounds for 17. Well, you know what? This one is already as a nice unit rate. So why don't we convert this into dollars per kilogram? You could take this one and, well, you could convert it into 10 pounds. It would just be complicated. So, and I'm going to start using conversion factors. So 10 pounds times, now a conversion factor starts with an equality. And in this case, we're going to use this one. Now, every equality, this gives me two conversion factors. It's 1 kilogram per 2.2 pounds, or 2.2 pounds per 1 kilogram. So really, you just take this and you write it both ways, right? So it becomes a fraction. And these are your two conversion factors. And then you go to your question, and we want to end up, we're converting this to kilograms. So if I put 1 kilogram or per 2.2 pounds, if we look at the units, and that's how you know you did the right one. Look at what happens with my units. My pounds are going to cancel off, and I'm going to have kilograms left. So I'm going to end up going 10 divided by 2.2, and I'm going to get kilograms. Or another way to do it is the units you want are the ones that go on top. So I want to end up in kilograms, so that better be on top. Okay, look, grab my other calculator and see if it is better on the screen for us. If I move it up there, 10 divided by 2.2. Oh. So that gives us 4.55 kilograms for 1740. Okay. Now this one was the unit rate, and it was dollars per kilogram. So let's convert this. So I want dollars per kilogram. So 1740 divided by 4.5. 17.40, 4.55, $3.82. So it looks like this one is the lower rate. So we've got 361 versus 382. And now thinking I should have left myself more room here. All right, we got 6 miles per hour or 2 kilometers in 10 minutes. Okay, since that's already a unit rate, let's convert this into that. So 2 kilometers, I want to convert that into miles, because eventually I want to have miles per hour, and that's where I want to go. So my 2 kilometers, now I'm going to multiply, and the neat thing about conversion factors, it's always multiply. You're always going to be multiplying when you're setting it up. Now my conversion factor here, I've got 1 kilometer over 0.6 miles, or 0.6 miles over 1 kilometer. Well, I want to end up in miles, so I'm going to choose the one that's got miles on top. So 0.6 miles over 1 kilometer. And I'm also going to double check, see, because now the kilometers on top and the kilometers on the bottom disappear. So 2 times 0.6 would be about 1.2 miles. Okay, so I got the top part. And now I need to take the 10 minutes times, there's no conversion factor up there, but my choices are 1 hour and 60 minutes, or 60 minutes and 1 hour. And I want to be converting into hours, so I'm going to choose the one that's got hours on the top. So basically, we're just going to go 10 times 1 is 10. Truth is, you're just going to go 10 divided by 60. I'll do it right. 10 times 1, 10. Now I've got 2 equal signs, sorry. And 1 times 60, 60. So 10 divided by 60. 0.167 hours. So we take and convert this to 5.167. Oh, my calculators. All right. Third time's a charm. How about that? That we can all see. So where am I? 1.2 miles divided by 0.167, 7.18, so 7.2 miles an hour. Miles per hour. So we want the lower rate. So good guess. This is lower. Ta-da! All right, 2 more. Fuel efficiency, 10.6 liters per 100 kilometers, or 3.51 liters of fuel for 450. Okay, guys, I'm old school. In the metric system, 10.6 liters per 100 kilometers. That's how you do gas efficiency. But you know what? I'm going to make it easy. I want to know liters per kilometer. It's going to make the math easy for us. So liters, 10.6 divided by 100. It's going to give me 0.01060. Oh, I better check that. Oops, clears. 10.6. Oh, 10.6 divided by 100. I can't believe it. What is my calculator doing? 10.6 divided by 100. 2 decimal places. All right, see. Feels like it's a Friday afternoon and really warm in here. Liters per kilometer. Or 35.1 liters divided by 450. 35.1 divided by 450. 0.078 liters per kilometer. So this one is the lower rate. I guess we could have taken this answer, multiplied by 100, and then been able to compare it directly to that. Just never been a fan of this metric, liters per 100 kilometers. But I'm old, and the math still works. So I guess there is multiple ways to have done this. All right, driving speed, 30 meters per second for 100 kilometers per hour. Pardon me. Well, these are both unit rates, so we could actually convert either way. I think I want to use, I'm going to convert this into these types of units simply because intuitively I have a better idea, and I'm sure you do, of 100 kilometers per hour as opposed to 30 meters per second. Because to me, that sounds really, 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 really fast. I have no idea if it is or not. All right, so 30 meters. And we're going to go for kilometers. So there are 1,000 meters is equal to 1 kilometer. And I don't even have to put the funky little dot on top because that is by definition an exact amount. It's not about that many. No, it's exactly 1,000 meters in 1 kilometer. So that gives me the two conversion factors. And I want to convert to kilometers, so I'm going to choose the one that has kilometers on top. Now, maybe this makes it more clear. We multiply through, see, my meters will disappear, and I'm going to get 30 times 1, so I'm going to get 30, and kilometers, right, that unit is left, and then there's 1,000 on the bottom. So that's going to give me 30 divided by 1,000. Can't believe I just did that. 0.03. Now, kilometers per second. You always want to keep track of what you've changed and what you haven't. Now, there may be some of you who are really good at conversion factors and you can just string a whole bunch of these together and do all the conversions at once. I am not that person. Okay, so now I know every second we do that. Now we want to go to hours. So let's make life easy. There's 60 seconds in a minute and 60 minutes in an hour. So that means there's 3,600 seconds in an hour. So my two conversion factors, 3,600 seconds per hour, or 1 hour is 3,600 seconds. So I want to take this answer in kilometers per second, and I want to make it in hours. But I also want the hours. Sometimes I hate conversion factors. But I also need my units to work out, and hours has to be on the bottom. So let me show you. 0.30 and seconds times. Now I'm running out of room. I'm sorry. Gotta erase what I just finished writing. 3,600 seconds per hour. Now, if we do the multiplication, my seconds are going to cancel, and I'm going to end up with kilometers per hour left. And I'm going to have 0. Oops. I lost a 0 there. Times, goodness, camera. $108 kilometers per hour. Okay, I'm going to fess up with you guys. as much as I'm supposed to teach you conversion factors, don't intuitively use them. Let me show you how I would do this. 30 meters per second. Okay, convert to kilometers per hour. All right, so it's 30 meters in a second, and then I would multiply that by 60. 30 times 60 should be, so that's going to be 1800 meters per minute. Okay, but I want per hour, so I'm going to multiply. There's 60. So every minute it's going 1800 meters, and if I multiply by 60 again, I'm going to get 108,000 meters per hour, and I want to convert this to kilometers, so we're going to divide by 1,000. So for meters to kilometers is always a factor of 1,000. If you're going 2 meters, it's multiply. If you're going 2 kilometers, if we're going 2 kilometers, it's dividing by 1,000. So by 1,000. Kilometers per hour. So I'm just saying there's more than one way to do these, and it's whatever works for you. Yeah, I'm going to leave it at that. Just saying that you could have also taken this and converted it into meters. So never mind. Might as well show you. Okay, so I want 2 meters per second. So 100 kilometers. So that's 100 kilometers times 1,000 is meters per hour. Okay, so that's always because there's 1,000 meters for every kilometer. That's in an hour. If I divide that by 60, so it's going to be 1,666.67 meters per minute, right? Because we converted. And then we're going to divide by 60 again to go into seconds. 27.78 meters per second. So either way, the 100 kilometers an hour is the slower rate. So whether you convert it to kilometers per hour or meters per second. And the nice thing about using the conversion factors is it's easy to see the logic progression, but it's, I don't know, for me, it's not intuitive. So I acknowledge there's more than one way to do questions, and I will always look at the work that you do. And as long as you're showing me some work, I think we'll be okay and we'll get along just fine.